Question number 13. In this question, we have to find out the value of D. The value of D is actually the distance between Dixon and Nora. Okay, this is the distance that we have to find out. And as we can see that in the diagram, that the diagram has two right angle triangles. Okay. And this is the first one, and then this is the second one. Okay, so what I can do, I can use the first triangle to find the length of the adjacent this side. Okay, first of all, I'll use this triangle to find out the length of this part. Then I'll use this triangle to find out the length from here till here. As soon as I have the length of both the adjacents of both the triangles, then I'll add them both together to find out the overall distance between both Dixon and Nora. Okay, so what we are doing right now we are going to consider the first triangle, the right angle triangle on the left hand side, and we will be finding out the adjacent of the first right angle triangle. So if you look at the right angle triangle on the left hand side, which I have highlighted, you can very clearly see that we have an angle 34 degree, and with 34 degree with as our angle of angle which we are considering. Okay, with 34 as our angle under consideration, so 123 meter becomes the opposite, and we are trying to find out the length of the adjacent. So the formula, the trigonometric ratio which we can use is tangent theta, theta is 34, is equals to opposite upon adjacent. Opposite is 123, adjacent is what we are trying to find out. Let's call this distance as x. So tangent 34, with the help of the calculator, we will find out the value of tangent 34, which is going to be 0.674. This is 0.674 is equal to 123 over x. As I have already mentioned many a times that when our variable is in the denominator, so we move the decimal, we move the variable to this side and we bring this value over here. What's going to happen? X is equal to 123 divided by 0.674. So I'm going to divide 123 with 0.674. I'll get 182.35. The value of X is going to be 182.35. This is the adjacent of the first right angle triangle. Then I am going to consider this triangle over here, and in this triangle I'll again find out the adjacent, and with 49 degree known, 123 meter becomes the opposite. Y is the adjacent. I'll use the same trigonometric ratio, tangent theta equals to opposite upon adjacent. This time the angle will be 49 degree equals to opposite is again 123. Adjacent, I have taken the adjacent as y. The same procedure, the same steps will be performed. I'll move y to this side and I'll move tangent 49 over here. So this will be y is equal to 123 over tangent 49. Let's calculate the value of tangent 49 with the help of the calculator. That will be 1.150. 1.150. Let's divide 123 with 1.150. What I get y equals to 106.92. So I can say this distance y, the adjacent of the first right angle triangle, is 106.92, and I can say that x, the adjacent of this triangle, is 182.35. Now that I have the adjacent of both the right angle triangles, what I am going to do in order to find out the value of D, I'll add x and y together. So what I'm doing, I'm adding 182.35 with 106.92. The value of D is going to be equal to 289.27, 289.27 meter. So the distance between both Lexion and LoRa is going to be 289.27. There can be a little difference in your value as well. Approximately this is 290. If you are getting your answer approximately 290, so the answer is going to be accepted. Okay, this is it. In the next video, I'm going to continue the next question. Thank you.